Hey guys, so at this point, you should have already watched the video in Google Classroom on the vocabulary words on the previous page. So you should have already filled this out. And now we're going to get into level 4. So you need to keep in mind that you're supposed to use the given information to justify why the two triangles are congruent. If there is not enough information, you can say there's not enough information, right? So let's get right into it. So let's always annotate the diagram just like we've been doing. So we know that AE is congruent to CE. So how do we mark that up? Remember, a dash. So or hash mark. So AE and CE are congruent. And then after that, BE is congruent to DE. So I'm going to also put a hash mark. BE and DE are congruent. So, and then they said AE and BD intersect at E. So I don't know if you remember when we just did the vocabulary words, when two lines intersect, right? What type of letter do they create, right? If you said X, that's correct. Now, since they form an X, what kind of angles are created? And if you said vertical angles, that's correct as well. So what angles in this case are vertical? So you should realize that this angle, since we're talking about the triangles, right? So this angle inside the triangle and this angle inside the triangle are vertical. So we can mark that up. So this angle and this angle are vertical. So as a result, are these two triangles congruent? And the answer is yes. Yes, by side, angle, side. All right. Now we're going to, after we come back from break, we're going to be doing formal proofs where we're going to lay this out step by step. And we're going to have to make this look a little formal and fancy. However, for now, if you're able to make this conclusion that the two triangles are congruent by side, angle, side, you're in good shape. All right. So this is the answer for number 1. All right. So we're done. All right. So now we're going to move on to to question 2. So what you should realize is that these two triangles are connected, right? But before we get into that, let's read the given. So DA, this line right here, bisects. So that's a key word, y'all. We just went through bisect. BAC. So it's a bisecting angle BAC. So this entire angle is being bisected. Well, what does bisected mean, right? Bisected means, and if you said it, great, it means cut in half. So this entire angle is being cut in half. So what do we know about these angles as a result of those angles being cut in half? What do we know about that purple angle and this greenish angle? What must be true about them? And if you said that they must be equal, then you're correct. So what we're going to do, and we also have to look at this information. Angle B is congruent to angle C. So we could put a little arc, and I'm going to put 2 so we know we're focusing on these two angles. All right. But now, what we should do whenever triangles are connected like this, we should probably draw them separately. And that helps me, and I think is going to help you as well. So let's go ahead and do that for a second. So this, and I know they don't look the same based on how I draw them, but we know they're probably the same. But we just have to prove it now. So we know that this angle right here is congruent to this angle right here. That's what we know. And we also just made a statement that this angle right here is congruent to this angle right here. And that's because of what reason? How did we know that those two angles were equal? Is because of this. The line DA was bisecting this entire angle, which split it into two equal angles. So remember that purple angle? That purple angle was this angle. And the green angle was this angle. And we said that those were congruent. So now you should realize that these two triangles share this line and this line. So remember, what is that property when they share the same thing? Go back to your notes, right? What is that property when they share the same thing? If you said reflexive property, you are correct. So this is known as the reflexive property. So now we just need to mark up the diagram a little bit more. So we just said that DA is congruent to DA. So we can mark it up. So we could put a little, and let me get a little different color. We can put a little dash here and a little dash here. So now, is there enough information to prove that triangle BDA is congruent to CDA? And the answer is yes. By which method though? So take a moment. Is it side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg? If you said angle, angle, side, you are correct. All right. And we are done with this question. And again, we're going to make this look a little formal and a little, put it together a little nicer, if that makes sense. And you'll see what I mean. You're going to just kind of like put this together in a better format. But if you are able to come to this conclusion, that's a good thing. And that's where we need you to be right now. All right. So we are pretty much done. Thank you guys for watching. In a moment, you're going to, not moment, but a little bit towards the end of class, you're going to do an exit ticket. But we are pretty much done for now. Thank you guys for watching.